Hello, everybody. My name is Robert Ronan, and I'm a principal product manager with the OCI Developer Cloud Adoption Team. Thank you for attending today's webcast. I'd like to thank Marcy Samuelson and Tara Van Cleve for putting this all together. We have an amazing presentation today from the NetFoundry team. We have Skip Barr, Cloud Solution Architect from NetFoundry. And if you have any questions during today's session, please put your questions into the Q&A area. We will also have a live Q&A session after the presentation, and we will spend that time answering your questions, taking those questions live. The webcast is being recorded, and we will make the recording available shortly after the webcast. Again, thank you for joining. And before I turn it over to the NetFoundry team, I wanted to take a few minutes of your time and go over Oracle's Container Engine, or OKE. This is Oracle's safe harbor statement. Basically, it states do due diligence if you plan on making a purchase decision based on the content in which you're seeing today. Oracle Kubernetes as a service. OKE is a managed, scalable, and highly available service that you can use to deploy your containerized applications to the cloud. It's all based on upstream versions supported by the Cloud Native Computing Foundation, CNCF, which basically means there's no vendor lock-in, there's no need to re-architect your application when moving from an on-premise deployment to a in-cloud Kubernetes solution. Basically, this slide breaks down how our managed service for OKE is deployed. Everything in red is managed by Oracle or OCI, and everything in gray is managed by you, the customer, and you have complete access and control to manage these services. The benefits are a faster time to deploy, better reliability, lower risk, and you as the customer can spend more time and resources building your applications, focusing on innovation.
All of Oracle's cloud native services are built on top of Oracle Cloud Infrastructure. These services can be categorized as application development, operations, observability, and messaging. Oracle provides several services that are combined with OKE that provide a robust, scalable cloud native service environment. For instance, fully compatible Kafka, logging capability with FluentD, native monitoring, notifications, events, API gateway, and so forth. The ability to run your infrastructure as code. This lets you run your own Terraform stack in the cloud through our Resource Manager UI. Functions and several other services that will assist you with the most demanding workloads. And since OCI and OKE are based on open standard services, you're more than welcome to bring your own open source software to use along Oracle Cloud Native Services. This slide contains a few examples of what Oracle has been doing with respect to the open standard services and supporting the Linux community in general. Oracle is a platinum member of the Cloud Native Computing Foundation and a member of the Open Container Initiative Linux Foundation project. We're very serious about open standard services and supporting the Linux community in general. Oracle is the only major cloud provider to deliver and support a unified cloud native solution across managed cloud services, on-premise and off-premise software, supporting seamless bidirectional portability of cloud native applications built anywhere. OCI provides bare metal machines, virtual machines, containerized compute, GPUs for performance intensive workloads such as AI and ML, and a variety of cloud storage options such as block, object, and file storage and archive. OCI offers an array of services for developers to build modern applications, and OKE uses OCI as the main underpinning platform for its services. We don't restrict users to a single programming language, so it's your choice on what programming language you want to bring. For instance, Java, JavaScript, Node, Python, Ruby, or any DevOps tools that your existing organization is using. Let's take a look at OKE and OCIR. OKE runs highly available Kubernetes clusters. It's developer friendly. enterprise ready and offered as a managed service. And it also keeps pace and compatibility with the CNCF ecosystem. OCIR, Oracle Cloud Infrastructure Registry, is a container registry service that enables users to easily store and share container images. It allows users to push, pull Docker with Docker CLI and pull images directly into their OKE deployments. So let's talk about open source initiatives, OKE and OCIR. Let's talk about value. So let's break down the costing model at a high level. The area on the left designates the functions that Oracle manages for our customers. etcd, master nodes, upgrades and supported in Container Engine dashboard. It's easy to upgrade the OKE master nodes and node pull servers, and you decide when you want to do those upgrades. So as a customer, what do you manage? Clusters, worker nodes, in your own OCI account and tenancy, which are shown here on the right. So what does this all cost at the end of the day? So the OCI registry is a no-cost service. You just pay for the compute and the underlying infrastructure services. The OCI Container Engine for Kubernetes is also offered at no cost. And you only pay for the resources that are essentially being leveraged. We touched briefly on OKE and OCIR. What I want to discuss here is OSOC, or OCI Service Operator for Kubernetes. OSOC is an open source Kubernetes add-on that allows you to manage OCI resources such as autonomous database, MySQL database, and other services through the Kubernetes API. You can manage OCI resources the same way that you would manage Kubernetes applications, reducing the complexity and any learning curve that you may have in your organization when adopting new technology. OSOC makes it easy to create, manage, and connect OCI resources from the Kubernetes environment using existing Kubernetes tooling. OSOC can also be used on Kubernetes clusters running on OCI Container Engine or outside of OCI. Everybody knows that you can definitely run non-persistent workloads on Kubernetes, but if you want to run persistent-based workloads, there's a couple options that we offer. Persistent storage allows you to run stateful applications, allowing you to provide services and capabilities for both stateless and stateless apps. Your apps can easily integrate with existing databases and services such as ATP, autonomous transaction processing, and also access existing persistent-based storage. Finally, here's a few highlights and features that we announced recently. Kubernetes version 1.20.8 is now available. Cloud Shell, Container Storage Interface, or CSI support for monitoring Kubernetes API server, and OCI audit service. We also support autoscalers, HPA, VPA, and cluster. And that concludes my overview of OKE and OCI cloud native services. I'll pass it off to the NetFoundry team. Skip.
Thanks, Ronan. Well, this is actually Philip here. I'm gonna just do a base set, a few key items that we want to give an overview on as to why this is a relevant topic. It's going to be really quick because we want to really get into the meats of showing a demo and how powerful it can be to do for anyone. So I work for NetFoundry. Our objective is to build next generation networking security. Why? Because organizations are digitally transforming. They're moving to Oracle Cloud. They're moving to Kubernetes and OKE because they want to have more velocity. They want to create new functions and applications and business value quicker. But we also need to do cost-effective security. We're very bad at this at the moment, just in general across the world, and we see that due to the pandemic of ransomware that we have. And we fundamentally believe that comes from the original design architecture of the internet. So this is an issue because delivering agility and security are competing objectives. And the way that we see resolving those competing objectives is to take away the infrastructure. When we remove the infrastructure, we can move faster because we don't have to deploy your traditional networking and security things like VPNs and Bastion servers. But fundamentally, we also eliminate the vulnerabilities that come with those types of infrastructure. And this is the velocity part is very well demonstrated from moving to the cloud from the first place. When you move to the cloud, you increase the velocity because you no longer have to worry about the data center and building those physical components. And the way in which we see this is zero trust. Zero trust has become the trendy term. Even Biden talks about it, but it's also been co-opted, and everyone slaps a zero trust label onto everything to the point that it doesn't really carry its original meaning, or it doesn't go far enough as to the principles of how we stop ransomware and other types of attacks. So in NetFoundry, we have these zero trust 2.0 principles, or it's kind of like zero trust if you take it to first principles. And the first part is that all networks are inherently insecure. And if networks are inherently secure based upon how the internet was traditionally built, that means you cannot trust things which have a internet-facing public IP, because those things can be brute forced or be exploited by a critical vulnerability or some other means. And therefore, what we want to do is to move zero trust as close to the application as possible, or potentially even in the application, have private zero trust connectivity inside the app with no exposure to the network. And because we don't trust the network, we can't trust IP, therefore we need to start with very strong identity and do authentication and authorization before any connection is established. And fundamentally, we also need to use least privilege access and micro-segmentation. Last but not least, we need to do everything as code with APIs, because only code can move as fast as code. And so with this in mind, what does NetFoundry private zero trust look like? Well, it starts by using incredibly strong cryptographic, public-private identity. And when I try to access a cluster or the Kubernetes API that sits on OKE, I say me, actually Clint and Skip, what I have to do first is I have to authenticate to the system using my public-private identity. And if I don't show that identity, there's no access to the system. The system is unreachable. Once I do put in my identity and validate to the system, and the system says I should have access to a single service or a single port or something running on OKE, then I get given access to that service, but only that service. And fundamentally, the Oracle Kubernetes Engine and everything that's running there stays completely dark, private, and unaddressable to the public internet, which means you don't even need an internet gateway. You can literally just have a NAT gateway of outbound internet. Nothing can come into that environment. And that means, well, fundamentally, attackers can't do network level attacks. Your OSI level, 3 to 5, your kind of DDoS attacks, your brute force attacks, your CVE exploits, your port scans, because it can't be found in the first place. And that enables us to massively reduce any attack surface in terms of how people are consuming services. And so what we're going to show today is two broad use cases, how we apply our private zero trust connectivity in an incredibly and simple way in order to access the Oracle Kubernetes Engine API so that we can replace VPNs and or Bastion servers and ensure, as I was just saying, that literally we run OKE, we have a NAT gateway, but only trusted users can get access to the API. Simultaneously, we will also show, it looks almost exactly the same, but instead of accessing the API, we're going to access services in the pods, the applications which are running on that environment, kind of like the more user perspective rather than the administrator perspective, where we can replace using VPNs and or MPLS, FastConnect, etc. And so I'm going to stop sharing. I'm going to hand over to Skip and Clint, and we're going to show this live in practice.
So that's exactly it. Just to kind of continue, I'm just going to take you through a few of these, kind of scenarios, get it kind of up and running for my half, and then I'm going to let Clint. He's one of our senior developers, to show you kind of taking it to the next level, taking it to embedding our SDK into the kubectl binary, and then also getting access to all this infrastructure. So basically, to get started, it's just a simple cluster, and let's just say when you're getting started, and the way it usually works with the create clusters, you say it launch the workflow. I did it with public endpoint, private workers. This makes it the easiest way to get everything kind of installed, then take the public endpoint away from it. So you don't have to have any type of Bastion host or anything like that. So my workers are still private. So it's just a base install. I did put a couple of applications into my environment. And you can see that I'm currently connected to my Kubernetes control plane on my public control plane. I do have some nodes. You'll notice they are, just like I said, they're not, they don't have externals. We have a few pods, and you can see I'm collecting my pods once again from the public API. And you notice that I have a Hello World pod running in here. And I also put an Ubuntu instance in there. I think it's running a web page or something else. But essentially what we want to do is try to take, okay, so I've installed my environment. I got it up and running. And let's just say you did it this way and you were hardlining, you were VPNing in, or you were doing some other method to get in. You could, if you had that public interface, the nature of when you build these, let me go back one and go back to create, either way, it does create, the internet gateway and a NAT gateway. And you'll notice my diagram, I did put it. So when we first get installed, and I'm going to take you through this picture a little bit, I do have that IGW there. Once I establish my connectivity to my software in this pod, then I can haul this away and take it out. And then it'll just be all egress will be through a NAT gateway. It's just, I just want to put it there. So when we initially set up, that's kind of how it works. So you think about, this is our software. We have your cluster running, fine. What do you need? I need my software right here in a pod by itself. I need my software installed on my Windows box that's also running WSL, as is Clint's. So he installs his software here, and that's the client. So you think in terms of these are all endpoints. In the nature of this demo, I've already created all my middle mile, my infrastructure. So we just have to really set up our endpoints, set up the communication and the services that we want to go after. So we want to go after maybe a hello world. We want to go after the API. So we'll show those two examples, and then Clint will take you through kind of the zetification of the kubectl binary. So right now, let's take you to our console for a second. Here, you notice here's what it looks like, and all those things we just talked about are all listed right here. So all comes down to routers, endpoints, services, and app WANs. And what we're going to do is we're going to build a service. And I've already had my endpoint installed for my PC, and I already have built an endpoint. And it's just a matter of hitting endpoint name and then hit create, and then you download it. So I've already kind of gone through that little process to get those downloaded my machine in the nature of speed here. So what I want to do is, okay, before I register, before I turn this pod up over here, I want to define my environment so that I can quickly convert over to my private connectivity. So what I'll do is I'll create these services, and I'll show you what they look like kind of over here. So it's just a matter of, I have a hello world service defined by hello ZD port 80. I have my private API service going to that address. And I have another one, Ubuntu web page. Yeah, so 3 services, not a lot. And we simply just upload those into the environment. So I'll come over here, I'll select the file. I'll say OCI webinar services, hit open, and hit upload. So that does, let me go back, it might take a few seconds. I did the wrong one, I think. Let's search services. Come on, it's taking a second, unless it went into endpoints. Might have to those. So one more time, hit open and upload. Okay. Should like those a lot better. So essentially what we're doing is we're defining services, and then we're going to tie them together with this construct called app WANs. That's also represented by these A's right here. So I'm going to get access to an app WAN that has access to the middle mile transit that takes us all the way. All of our endpoints have access to this middle infrastructure to give us that ability. Let me get my service up here. I don't know if it's coming in yet. I have to refresh it. And you'll notice on my client from my PC, I have, this is my PC, my endpoint on the diagram. I have no services defined. And these guys are not coming in yet, doesn't look like. So let me put that in here. CI. Okay, here they are. So I have Hello World, I have OCI Private API, and I have my Ubuntu services. So I'll come into AppWan, and I have one pre-stage. So it's an AppWan you just build, and this basically just gives you exposes the services. OCI demo AppWan. I have myself and Clint, and then I have another SDK implementation as well. So I'll choose. You know what I have? I have OCI webinar. You'll notice that by being able to give those an attribute of OCI webinar, it populates 3 services into what my AppWan will be and gives me access accordingly. So then I hit update. And quickly you'll come down over here and you'll see this should populate with a 3. There it is. So now just like that, I've been granted to that. Once I register my endpoint in the pod, I will get access to that. I don't have it yet. I'm being exposed to, I'm being shown that I have it, but since we haven't installed the other piece, that it won't actually work. So going back to the picture again. So all of this is installed with our pod is installed with Helm. I have Helm in here. So I already have pre-installed Helm, and it's as simple as installing that into that chart. That chart can be found on our NetFoundry GitHub, and you can find it under charts. ZD host is the name of this chart. And then you come back over here, and let me get all this other stuff out of the way so I can put it over here. And we'll come over to, let's just say the first time you run it, you have to install our repo. Get it once I copy it correctly. Okay, so I've already got it, so I don't need to do any updates, but if you would have to update, you can also update your repo. So what I'll do is, since I've already installed this, if I look at my identity, for this identity, the one I want to install in Oracle is right here, Oracle Demo Pod Identity. It's a JWT file. It represents my identity within the fabric. Doesn't matter what my IP is or anything. So what I'll do is I'll install this specific. Okay, so Helm installs our ZD host that we pull from the chart, and then it sets a file to my enrollment token for this is Oracle Demo Pod Identity.jwt. So in order for this to survive, I should show you one more thing. I have installed a persistent volume, so I can have this key and resulting JSON file persist through a destruction or compromised pod of some kind. So I can just delete it and it pops back up with all of its associated data. So I already have that. Let's go back and put this in here and let it go. All right, so that sends it out over the public. So I'm going over public, installing our software to the public interface. And this can take a few minutes as it downloads the binary, and then it pops it, starts up the tunnel itself. So I don't have to go through all this exporting of namespace and things like that, but we can just go get pod. And oh geez, of course it happens to me. Okay, not a problem though, because what we can do is try it another way. So it's always demo shenanigans, right? So now I have a different pod. I have a backup one. So I'll go get pods, same thing. And I'll go K is short for kubectl. I'll go, I have those same 2 pods in there. So I'll run the same exact Helm chart file for this right here.
And just for anybody paying attention to that JWT file, this is Clint speaking, developer on the OpenZD project. That JWT is a one-time use token. So you download it from the platform like Skip has shown, and then that token is used to do the enrollment of the pod, in this case, the ZD host pod that we're installing. And that's when your private strong identity gets created, and it never leaves the process space or the Kubernetes space itself. Just wanted to point that out while Skip was doing that.
Right. Thanks, Clint. Okay, so right now, that's what we have. So I've gone to this backup cluster. It's a different cluster altogether. And what we want to do is do the same thing. I have, let me get back over there. All right, so I have the, you'll notice how my ZD host is running. That's good. So now I've really achieved, well, on this diagram, I've been able to get that installed. So now I can go, I have access to this via this channel. That means I can go to the private method only. So come back over here to the backup cluster, webinar cluster back, and same thing. Come over here to quick start, access cluster, local access. And this time I'll create a new config based on my private right here. So I'll copy this for private endpoint, copy that, come over here. No, didn't copy it. All right. So that should create. Now I have a new config with the new cluster. You'll notice I'm going to change this. I'm going to be 443 because that's what I defined my service with the other cluster. So I'll just delete that. This is how I consume it. Okay. All right. So 443. So now I'm, if I go, okay, get pods minus v6. Oh, I'm still going after that guy. Okay. So, so export. Config. Where did I miss that? Kubeconfig.
I think you want the equals there, not a colon.
Oh yeah, right. There. So now I should be going after that that old one. I mean the private one. Assuming everything's the same, which it won't be, I guess. I'm gonna have to update that. Okay, so we're gonna do kubeconfig, and we're gonna update this IP to .7 so I can get access. So we'll come back over to the NetFoundry console. This just shows you how easy it is to change the service. This was set up for the old service, so we'll come back over to private API, take that out, put in 10.0.0.7. We did change the 443 already, so we'll come back over here, hit update. All of this needs to be changed as well.
I think this is a really great demonstration of NetFoundry's zero trust idea too. Lots of times in zero trust, you'll see an entire CIDR block that is whitelisted. Skip had literally whitelisted a single IP address. So it's an IP address that doesn't exist on his local system. It's a 10.0.0.7 versus 8. That's a major differentiator, is that very segmented approach to what services are defined, including the port, as you saw. And also we can see how Skip has remapped the port from 443 to 6443 as well.
Okay, so right now we're fully accessed to privately. So what that really ultimately means is you can come back into your to your cluster, close it down, edit, drop the public IP, and hit save. So this kind of is the picture we showed over here where, okay, we got started on IGW, take that guy away. Now he's kind of going back to the method NAT gateway, fully dark. Well, once it's implemented. So now I have access to that. Additionally, I should have access to hello.zd from here. Yeah, so that's the pod neighboring over here I have access to via my client that I'm on. And I'm not sure that I need to probably correct the Ubuntu as well. So that guy's probably going to be, let's go get that guy fixed, and we'll just show that one as well. So if I come over here and see here, we'll go, okay, describe pod Ubuntu. And then this guy's IP is right here, 10.244.1.3. Good. Let's come back here, fix his service. His service is right here. Okay. And this is his real address. This is how he's served on the bottom. You see host configuration right here. That's how he's served. This is how I consume him. I made up a name, apache.zd on port 80. And I'll hit update. And I can come back over here. Once that hits, that IP, apache.zd should hit pretty soon. Then I can come over here, do the same thing. Might take a few minutes to get through the system. Sometimes it does. So, and that at all the same time, the public's going, he's still making his change. The public's disappearing. So now fully private managed remote Kubernetes cluster access and private API. So that's kind of what I want to show you. This the way it can be very agile. It's like just like you saw it real time on the fly. Go to a backup cluster, never been touched, boom, and then be able to get it up and running and pretty quickly. Anybody have any questions?
We actually do have some questions that came in. So the first question is, how is NetFoundry Zero Trust different than anyone else?
Good question. Most Zero Trust providers do a combination of traditional technology. So, your traditional VPN together with inspection authentication via your kind of traditional firewall. And it's kind of an extension upon the original concepts of inspecting a user. We don't do that. We have identity on the endpoint, as Skip was showing, that we put into the Docker container in OK as well, which effectively means that we're using authenticate before any connection can be established. And this enables us to ensure that the environment is completely dark, completely unreachable, because all communication is established outbound from the container in OKE into our hosted fabric, and likewise from Skip's laptop outbound into our container. So not only can you not be subjected to network level attacks, but you also don't need to faff around with changing firewall rules or setting up any of that network infrastructure in the first place. Instead, we can just use APIs or the GUI, as Skip was showing.
Excellent.
Yeah, actually, I'd like to add one little bit on top of that, if I might, because NetFoundry also takes a different approach. We have the OpenZD project, which is an open source project that you can go out and download right now and take a look at. So we have an open core model, which is pretty awesome. But what really is awesome is the app embedded Zero Trust. So we take Zero Trust right all the way into your application itself. So, historically, you'll see lots of zero trust providers, as I mentioned before, they'll open a site or block range, and that will be, the IPs that you're able to access. You might be able to filter down to the port, which you're allowed accessing to. With an app embedded approach, which is really revolutionary, you can take that zero trust, that strong identity, bake it directly into your application. So now not only do you not trust the network, but you don't even have to trust your local operating system anymore, because that trust is baked into the application. And then should your application get compromised, and as everybody says, it's not a matter of if, it's a matter of when. But if your app gets compromised, the blast radius that your application can affect is dramatically limited by having app embedded security. That app is only permitted to talk to network resources, which that identity has been authorized for. So the kubectl, for example, if I were managing a Kubernetes cluster using my strong identity, and somehow my kubectl command was replaced by some nefarious actor, I would only be able to access the Kubernetes cluster. Now, of course, that's terrible, because Kubernetes, that is a high value target. But if I had a SQL Server database somewhere else, I couldn't access that SQL Server database. If I had an HR system somewhere else, that compromised application can't access the HR system. So that's a huge differentiator, in my opinion.
I think you also very nicely lined us up to give a quick overview of the kubectl, kubectl, and your work embedding zero trust into it.
Well, thanks, Philip. I would be happy to show that off, because I think it's really cool. Just like Skip did, I went out and I made a cluster in OKE. I already have it turned off. It has no public IP address. So here's my cluster. I don't have any workloads in there. I'm just demonstrating access to the Kubernetes API by itself. Here's my little cheat sheet of commands that I'm going to run. And I have a terminal window right here. And hopefully this doesn't block anything. The zoom controls up there, always causing trouble. So you can see I have a kube config that is OCI private, and I have a kube config that is Clint's minikube. So basically I have, using ZD, I have installed that Helm chart, just like you saw Skip do, in my Kubernetes cluster, as well as in my minikube. And I've registered both of those endpoints in my current ZD network. So I can easily access both of those Kubernetes clusters. And like Skip, I run the ZD Desktop Edge for Windows. So if you were to look at my client here, you could see I have a Kate's Clint minikube, as well as a Kate's OCI service. When I created my service, I actually used 2 different names for it. Another really cool differentiator for the NetFoundry, the OpenZD stuff, this ZD Desktop Edge for Windows and all of our tunneling apps, they allow you to just make up any DNS name that you want. You saw Skip use, I think it was apache.zd. Like, that just came out of nowhere. .zd is not a top level domain whatsoever, but he could use that because he's running this special piece of software called the tunneler. So I also am running the tunneler. I have mine on. And if I were to go to 10.0.0.6, you can see I can get there. It's just like Skip did. If I were to look at the certificate that's presented here, and the subject alternate names, you'll see Kubernetes, Kubernetes.default, Kubernetes default service, blah, 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 right? Kubernetes, when you create a cluster, it gives you a certificate that is valid for all of these domain names. And that's the other reason why I have Kubernetes.default.service, as well as Kubernetes.default. So I had to get a little Kubernetes.default. I had to get a little creative when it comes to .default versus .service, one of which goes to my minikube, one of which goes to Oracle's, the OKE instance. But right now I can use kubectl. I can pass that Oracle config, and I can get my pods. And you can see I'm running that ZD host that Skip installed. But I can just change my kube config. Actually, my minikube is not exposed to even my own local network. While it is running back here in my Ubuntu virtual machine, which is right here. I'm not going to show that just yet, because one of the neat things I can do is I can turn off my ZD Desktop Edge for Windows. And when I do that, I will lose access to the 10.0.0.6 IP address I was going to before. It will just stop working. And my, I'm going to do the v6 thing too, because that way you can be sure that I'm not going to some nefarious IP address. You see, I can't connect to 10.0.0.6, although it's not telling me because it's going to time out. I think I need a v7 on this one. There it goes, 10.0.0.6. So I can't access this whatsoever. Now, like Philip was saying, we have taken and zetified the kubectl command, kubectl. I just keep screwing it up. So if I keep saying kubectl, 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 you'll know what I'm talking about. We've zetified it. It's out there under the OpenZD umbrella. So if we go to the OpenZD incubator, that's what it's called, incubator, kubectl. You'll find it out here on GitHub. You can see how we've done it. I've already downloaded it, obviously, so that's not, we don't have to download it, but if I were to go, if I were to go back to my cheat sheet so I don't lose my commands, in my little kubectl example, I can use, well, in fact, I want to use kubectl, not kubectl. I can specify the identity file. This is the strong identity that I have to present before I can get onto the network, as well as the service name. You saw Skip made a service. I also made a service. So now I should be able to type kubectl and access my Kubernetes cluster entirely securely. No ZD agent running. I have simply taken the zetified kubectl and used it. So that's really cool, right? So now I have absolutely, utterly private access. I have this little slide right here. My machine has only public internet. The pod only has public internet, and we are rendezvousing over the ZD overlay in order to access that Kubernetes cluster. Now, what's even cooler about the zetified kubectl is that I can, if I do it right, I can modify the oci.private file, go to the bottom. I've already done this ahead of time, and I can just actually stuff those two exact flags into my kubectl command. So now instead of specifying all this noise, I can just specify the right config file and get pods using that, and this will succeed. And then since I am a lazy kind of guy, I have two aliases I already set up. So I can do a K Kubernetes for CD for Minikube get pods, KOCI get pods. And now you'll see, you can already tell, I did not have the Hello NetFoundry app installed in my Oracle Kubernetes cluster. I do have it installed in my Minikube. And so there you have it. It's as easy as that. I have two zetified Minikube and Oracle Kubernetes clusters. I can access them easily by just replacing the config file that is given to me by Kubernetes. Obviously, I need to have some private key information and to have that ZD network in place. And so that is what we call zetifying an application. So now that kubectl command is zetified. It needs this ZD identity in order to be used entirely. And that's my whole little dog and pony show.
Thanks, Clint. So if you stop sharing, I'll bring up my screen quickly. So what we basically just saw is by putting in ZT and NetFoundry into our OKE pods in our cloud, is we were able to get access to the API as an administrator while it's completely private and unaddressable on the internet without having to deploy your traditional VPN or Bastion host. And simultaneously, we did the same thing, but to access the services in the pods. One time that was with using our ZT Desktop Edge. Another time it was Clint showing it with the zetified kubectl. And fundamentally, this comes down to the fact that we've built a zero trust application delivery platform that enables us to deliver that zero trust 2.0 with embedded identity, so everything is outbound only, and therefore you cannot be subject to network level attacks. Where we combine it with programmable software-defined networking so that DevOps can use it. You don't need to be a network engineer anymore. You don't need to go to the network team. You don't need to go to a telco. You can just deploy connectivity instantly using APIs and connect it to anything. We showed remote access, but it could simultaneously be connecting to another Kubernetes cluster on-premise or in another cloud. It could be connecting to an application somewhere else. It could be going to a mobile device or IoT. And it's all based on software. And because, like Oracle, we also strongly believe in open source, we open sourced our technology, as Clint was saying, ZT. It's both a delicious Italian pasta, but it's also modern programmable private networking that enables us to do everything in a cloud native manner. And it also enables us to put connectivity absolutely everywhere. Clint showed you us putting ZT inside kubectl, but we can also put it inside a Java database. We literally just had a session today on what we call ZDBC. So we've put ZT inside the JDBC. JDBC is the Java database wrapper. It's like the API for your database. But we can also put it inside your Java application or your C application or your Golang application. We've worked with cloud native companies that asked us to build zero trust webhooks so they could pull code from GitLab in a private repository into their Kubernetes cluster, also running in a private environment. We've designed our core open source ZT to be able to go anywhere and everywhere. We can even inject into your browser. You don't even need to get a network person to load an application on your device. We can literally inject it into your browser, so it's completely frictionless. And this effectively enables us at the point where we can have fully private Kubernetes run on OKE, OCI, and to have it built in by design, to have it running in the application, to have it running in the cluster, to have it running in the VCN, so that we don't have to deploy VPNs, jump servers, data diodes, private APNs, all of the traditional private networking solutions, maybe even a firewall. You possibly don't even know that. And this enables us to give better user satisfaction, improve time to revenue, or developing the new application to decrease cost, to massively increase security. And over the last few months, what we've been doing is a lot of work with Oracle. This is one of many different blogs that we have around the autonomous data warehouse, around Kubernetes, around different things that we've done in our partnership. And fundamentally, the other also very awesome thing is, as you were saying, Rob, anyone can go and use Oracle always free. Develop an application, try out a new service. Similarly, we have our NetFoundry sign up where we always have a free tier as well. So together people can start testing. You literally go to the Oracle website, you can go to the NetFoundry website, you can build your own private OKE cluster using just software and APIs, and see what it can do for your organization. How are we doing, Rob? Any more questions popped up?
We do have one other question. So with regards to the benefits in contrast to cost, maybe you can talk about that. I know you covered free tier, but maybe you can go a little bit deeper into that.
Yeah, it's a good question. And there's multiple different ways you can look at it. Compared to what, it depends what you're comparing against. Something like FastConnect. FastConnect is really cheap, but going and buying an MPLS connection off a telco, it can be crazy expensive. So, we can very often save a lot of cost by not having to go and procure the MPLS, the cross connect, etc. Simultaneously, the Bastion servers and VPNs, there are free options on Oracle Cloud, but for a lot of organizations, the biggest cost for them comes the management, the operations, and our incredibly low hassle, no maintenance through our automation orchestration. For a lot of organization, it massively decreased their cost. We work with an organization that runs on Kubernetes, and they're an ERP company. For them, they're able to reduce their costs by 50% by not having to deploy and manage VPNs anymore. And at the same time, you also have the aspect where, compared to other clouds, Oracle is actually really cheap on egress, because you've designed a network which is much more powerful because it does the abstraction at layer 2. If you use the internet, though, there is egress. If you use FastConnect, there is no egress cost. If you use NetFoundry, even though we're going over the internet, and even though you can't be subjected to the normal internet network attacks, you also don't have an egress cost with NetFoundry. So it's almost like having a FastConnect, but over the internet. But then you're able to attach it to anywhere because, as we showed, you can take it to a laptop, a mobile phone, another data center, anywhere that basically has internet and the ability to run our software. So there are multiple aspects that enable you to be more cost effective, whether it's reducing the cost of having to procure other licenses, potentially reduce operating costs, you reduce the egress costs, but more importantly, to be more secure, to be able to move faster and generate revenue faster as well.
Great. That was excellent, guys. Hats off to the NetFoundry team. This was a great webinar, great presentation. You hit all the questions that came in a significant amount of depth. I really appreciate your guys' time. This was excellent.
Thank you for having us. It's a pleasure.